So we broke bread 2 nights ago here at ICC 2025, and I was basically blown away by your knowledge of data flows all the way from ERP down through MES and SCADA and all the way down the control stack.
Thank you.
So thank you so much for offering to record a little conversation.
No problem.
There. So why don't we start off, if you would, let the audience know your name and a little bit about your background.
Sure. So my name's Dan Prudhoe. I'm currently a senior solutions engineer at Solace, which is a platform for developing event-driven architectures. But for previous 15 years, I was at a large chemical manufacturer, focused in the industrial application, manufacturing execution, and analytics space. Large ignition users, a few hundred ignition gateways deployed, a lot of fun projects and lessons learned along the way. And now this year, made a transition to the vendor space to try and help manufacturers become more real-time beyond the plant floor, all the way up to the cloud and across the enterprise.
Love it, love it. And you are famous for being one of a cohort of people that was way back in the beginning of Ignition. So I'd love to hear, how did you get started on Ignition?
Sure. So yeah, we first contacted inductive automation at the end of 2009. And it was actually factory PMI and factory SQL, looking for really Unix-based or Linux-based industrial application platform. We didn't really want to go to Windows. We were using a very old Unix-based SCADA platform.
Nice.
And despite the challenges of working with such an old platform, one of the reasons it actually was very successful and was running at a handful of plants was that a lot of the legacy ERP, MES formulation stack was actually quite mature. And it was a custom build. And basically the MES system could automatically receive formulas from the ERP and then transform them and interpret them into a recipe that could then be executed by this Unix-based system.
Excellent, excellent. That's not easy to do on a Unix-based system.
It was not easy to do, but it was really a custom build solution and enabled this really strong IT ownership of kind of a piece of the OT stack, and that kind of started what ended up being a lot of the journey to come.
Love it, love it. So one big question that I had, why don't we go into like tutorial 101 mode? If you would, an MES, just give the audience a description of what is an MES, why does it exist, and then from there we'll kind of dive deeper into the stack between ERP all the way down to SCADA.
Sure, and MES, right, can have quite a few different definitions. In my history, primarily production tracking, right, so work orders coming down from the ERP, tracking equipment assignments, material consumption, operator assignments, quality tracking, so doing your tests, and then remediation of any quality issues and adjustments to material consumption based on that, and then facilitating in our case, like a filling and packaging setup, so managing all the different set points that need to go onto a filling line and all the equipment there, and then also management of receipts and shipping, so material coming in and out of the factory. Back then, OEE, which is a pretty common component, was not part of that, and that was actually part of the Ignition journey that came shortly thereafter.
Very nice.
And I realized I didn't fully answer the question you said before. We wanted to get off that Unix-based system and found inductive automation, and I was actually at the time in data warehousing and analytics. So I was not in the manufacturing space, so I didn't have a whole lot of context for the software, but it was kind of crazy to me that it was all this old kind of Windows and restrictive licensing. So I just kind of went in with this assumption that, well, something has to exist that's more kind of built on open standards, and there really wasn't. But then we came across inductive automation, reached out, started that conversation, played with factory PMI, and then shortly after, we actually were in contact with Inductive. They were like, hey, we're actually kind of rebranding this, and factory SQL is actually going into the Java side, and it's going to be called Ignition. So we'll give you a beta version. You should start playing with that. So we actually started developing with the beta version of Ignition probably, I'd say December 2009, January 2010. Nice. And our focus, because we were nervous, Inductive was a young company, was really about what can we do that's kind of safe for us to learn the platform and kind of grow in maturity. So we focus more on the analytics side. So keeping that old Unix-based system in place and really building an analytics suite. Say we can tie into these PLCs, we can tie to the MES, let's start unifying this data, putting it into a SQL database. And because the licensing allowed the 2-hour trial mode, we were able to build like a full-blown batch analysis application.
Nice,
and then go to the factory and show it, and they loved it. And then it was just, okay, we just have to buy a license. And then we were able to rapidly scale that to many other sites because of the standards right, and the stack above it, and that Unix-based system.
Yeah.
From the analytics side, then, we had comfort. We built a relationship with Inductive to start tackling the actual SCADA in industrial systems.
Ah, very nice.
Yes,
very nice.
And then over the course of maybe the next 5 years, the analytics piece kept growing. There were OEE solutions, various other different types of requests would come in, right, for different problems from factories, and then replace that Unix-based system with batching on a common platform, kind of utilizing that same ERP, MES formulation stack that we already had. And then really what was cool is we just kept gaining ground, and we were able to continue to expand and move into material receiving. There were some SCADA applications there, material transfer, so from different, there's a manufacturing process, but then you have to transfer the product through QA and then over to filling and packaging. So we got in there, and then finally into actually filling and packaging. And really leverage this same core ignition infrastructure. So we had a base gateway, and everything would always be modified in a manner to accommodate the new type of functionality, but retain the old. So we could basically stand up any one of our systems off of the latest version of that core system.
That's great.
And because of that, we were able to really grow to 60, 70 SCADA applications deployed, maintained in-house that were upgraded every year.
Yeah.
About every 12 to 18 months, if you got a new project, any kind of enhancement, we would always give you the latest and greatest version.
Nice.
Not always the latest ignition version, but always the latest and greatest version of that application. And we like to think of that as kind of a force multiplier, because anytime you'd say, oh, we have to change security or navigation or some enhancement to alarming, within 2 years, every system would have that.
Yeah.
Yep.
And it was that really stood out to me as I was talking to you and some of your former teammates at dinner. You guys were very conscientious about making everything modular, making it possible to upgrade. And I mean, you modified the ERP along the stack, and you're standardizing across, how many plants was it?
Yes, sites for like the mission critical systems, I'd say in the 30s.
Okay.
And then 60, 70 for the analytics piece. So there were some, some sites don't have as much automation to rationalize that. It's much more capital investment to actually do full-blown automation versus maybe there's some various PLCs and HMIs that we could just collect data and store and do analytics on.
There you go. And some of them might not even have had the fundamental industrial networking in place to be able to fully adopt ignition.
So we still tried to come up with, even our analytics applications, a minimum footprint to say at least there's it's not a full-blown SCADA, which is going to be very expensive, but if you can at least get us these 4 values from a filling line, we can give you this suite of ignition screens. And if you just get that, we'll deploy it, and we can do it very quickly.
Yeah. That was one of the things that impressed me the most. In a previous life, we would have called those compatible units, but the theme is modularity and like thinking in advance of how can you make this such that you can upgrade other systems, but just as importantly, you've got your 30 to 70 different plants. They're at different stages of maturity. It's like a history museum out there in terms of what automation is installed where and what networks are installed where. And that was one of the more impressive case studies I had seen of just thinking through that entire chessboard in advance.
Yeah, and it was challenging at times because anytime you try and have a standard, you immediately hit something that breaks the standard. So you have to start thinking in terms of how do I build a standard that's meant to have flexible standards. And eventually you settle in. It would always be the first few systems would be a lot of rewriting, and then you have to make sure you can test that in the backport to the original system. But then usually by the time you're 4 or 5 in, hopefully you've hammered out most of that variation. And that was our experience and able to get that scale up.
Nice. And a side question I had, did you work with a large system integrator? I get the sense that a lot of that development was done in-house by your own automation team.
Yes. So it was actually a collaboration between industrial software team and then the industrial controls team.
Okay.
And so I like to think that the software side helped keep the control side reined in a bit to help negotiate those standards and say, can we design it this way so we can scale more? And sometimes that meant having tags you didn't need in AOI. So you might have an AOI and you can put all your configurations for what a valve is or what a meter is.
Nice.
And it may not always be used, and sometimes varying personalities might be opinionated on, what should you have there. But generally, once they saw the scale, once the factory saw the support they got, and the controls engineers saw the support they got, I think usually a new person, they'd come around after a few installs. But yes, it was all in-house, integrators for some electrical work, things like that.
But the bulk, the core of that
generally, we found ourselves taking over integrated systems, external integrator systems. It's just tough because the needs of the factory change a lot.
They do.
And it's not always easy for them to kind of go back to the well to get more money to make a change.
Yeah.
Sometimes there may be stipulations right in their service contract that they can't make changes because then they lose their support depending on how crazy they get with their changes. So and really to us it was just like another software system. So the same way that your formulation system or one of these other ones, right? It gets updates. It has a project request queue and gets governed and distributed. So we didn't really see it that differently on the OT side. There's unique challenges and differences for sure, but it was not that different.
Okay, nice. That's great. So if I kind of zoom, that was the first half of your journey. Zoom all the way to present day. Like now it's 2025.
Yep.
We're sitting at ICC. You and I are hearing amazing announcements all week from all of these vendors.
Yep.
But what are your latest thoughts as you're absorbing all of the most recent announcements? MQTT, anything like?
Sure.
Your call.
Specific to this week is just that inductive automation continues to amaze, and the features they're building, it really feels like they're not even trying to compete with what you think their competition is, right? Yeah. It's not competing with some of the other types of industrial application platforms. Now it's more checking all the boxes to really be like a full-blown enterprise system, IT approved.
Exactly.
So secrets management, infrastructure as code, the full API access.
You could really feel that. And you and I were just in the Axelon session as well. Between Axelon and inductive automation, you could really feel that this is an enterprise-grade stack. So I was getting pretty excited.
They're already ahead, and they're just pulling farther ahead. In general, for me, 2025, so I work at Solace now.
Yes.
And Solace is, like I said, a platform for building event-driven architectures. About 5 years ago, it was 2020, we've been following a lot of the content online with Industry 4.0 and a lot of the direction things were going. And I was maybe a little late to the game, but came to realize some of the value of where adopting MQTT could help us.
Nice.
So as we deployed these systems over the years, there's different functional areas of the factory, and usually they would get their own ignition gateway because then those can be upgraded and deployed and taken down and put back up without shutting the whole factory down. So you kind of logically distribute your systems. Sometimes those systems then would have the need to get data from another system. So maybe do an OPC connection, you pull a couple tags from here. The analytics piece that was at all those factories, well, it wanted to talk to everything. So it's going to the database, it's making its own connections to the PLCs, or it's making its own OPC connections to another gateway. And what starts happening when you have multiple ignition gateways, multiple teams, it starts to get a little unruly, and it's hard to manage change. It's hard to manage dependencies. So you'd have a lot of like big sites, and someone would upgrade something, and then stuff would break, and you had to chase it down. It was very reactive, and no matter how much you tried to like paper manage it, it just became difficult. So looking at like what SparkPlug-B offered, I was like, hey, so we can start decoupling this, and actually instead of having this same PLC register be referenced 5 different times through this kind of spaghetti web of integration, we could actually really have like a single model for this and publish that out, and then have all of the systems read from that same tag structure. And they could still do reference tags, I guess. And if they really wanted to, they could do different names, but generally they didn't. So
interesting. Okay.
So it was kind of breaking out the devices and the applications, and then where applicable, even splitting applications. And so I think the mindset used to be, more systems is more complexity. And you hit a point, and it's very much similar to the thought of like monolith to microservices, that actually having more discrete units of capability deployed makes it easier to upgrade, to test, and to validate, and to deploy, and especially when it's distributed amongst teams. And Sparkplug kind of started us down that path of thinking that way.
Nice.
From that, Sparkplug then led to just becoming more familiar with MQTT and realizing it's one thing to go into ignition modules and you do a transmission, you go to engine, you do engine, okay, the tags show up. How's this different than a gateway network? Okay, whatever, it's just some settings. Then you go into MQTT Explorer, and you can go over here, and all of a sudden it's showing up again. And you can browse and see the data flowing, and it's super lightweight, and it's barely using any bandwidth. So this is pretty cool. And then realizing, let's go beyond Sparkplug, you can kind of build your own topic hierarchy, right? Your own namespaces and use them. So I started to get the bug a little bit of like, there's some really cool stuff you can do here. Systems that would, again, not only for tags now, connect to each other for a gateway tag change script or a gateway timer script. Every 30 seconds, I'm going to go see if this system did something, and then I'm going to act on it. That could now be expressed as an event.
Exactly.
And published out and then consumed. It was doing that evaluation, I started to realize some of the limitations on MQTT. That MQTT is great. It's lightweight. It enables the tag sharing very well, but for transacting, it was a little more challenging.
Okay.
Even with QoS1, you don't always kind of get the guaranteed retry. Or what if the transaction fails for business logic, or what if you want to discard this message, or if the database that the receiver or subscriber is dependent on is down, well, now you have to like buffer it yourself or do your own retry logic, and it gets challenging. So searched around a bit, and that's where we came across Solace. Okay. And so Solace is a message broker, event broker. It supports MQTT, but it is actually multi-protocol. So it supports AMQP, JMS, REST, and then also its own internal Solace protocol, can bridge to Kafka. So it was had a lot more features, and it was very robust, and that was intriguing. In particular, to start even just REST.
Yeah.
So now I could have messages published with MQTT. They could be queued and then delivered to a web dev endpoint at Ignition. Nice. And it's not going to dequeue that message until I get a 200 response from that web dev. Nice. So if something's down, I can just reject the message. It's going to retry. If it fails too many times, the broker can send it to another dead message queue where it can then be ingested somewhere else to say, hey, these messages were just never going to work. You can do time to live on messages. MQTT 5 has that, but at the time we were more MQTT 3. So there were a lot of cool features there. And the other piece was we wanted to decouple the sites in the cloud. Okay. So meanwhile, cloud adoption's growing. We want the analytics platforms are much more powerful there. You can provision services in the hyperscaler much easier. Yeah. So how are we going to get data and messages coming here? Like we can exchange locally. How do we get those exchanging up in the cloud? So can the broker do that? And a lot of brokers had different like forwarding mechanisms and things like that. But another feature of Solace that was very compelling is we call it dynamic message routing, or more informally the event mesh. Yeah. And so basically that is you can have broker clusters distributed across edge locations, across multiple clouds, on-prem data center, and they all become aware of each other, and then we'll intelligently route subscriptions between them. Nice. So if I have 30 factories with their own broker, communicating, facilitating controls, facilitating interaction between systems, I could have a broker in the cloud with a single subscriber that says, give me all Sparkplug data. Yeah. And it's actually going to Sparkplug's QoS 0, but it'll actually, if you want it to be guaranteed, it'll guarantee those messages from the broker to the cloud broker, and then queue on the cloud broker to make sure your consumer's there to ingest it into your time series database. Yeah. And
all the way through, it can validate that entire chain that the message made it across.
With the guaranteed messaging. And what was really cool with Sparkplug, well, I still love Sparkplug, is as we were changing our applications to be more decoupled, basically what it turned into was, by default, by nature of you upgrading your system, we historized every tag. And it was millions and millions of tags. And Sparkplug was, there's a coarse topic structure, which there's some trade-offs to, but with protobuf and with the tag pacing periods where you can kind of bundle up your changes, and the true report by exception nature, we're able to get millions of tags flowing and historized.
What historian were you guys on?
So this was in Azure. Okay. And Azure Data Explorer was actually what we were using. It doesn't really matter which one you use. That was fair. We'll just say the selection of that was more based upon the fact that I had access to Azure resources, and I could just click and provision it, and I didn't have to go through as much approval.
Yeah, I'm willing to bet IT supported you in that decision.
Yeah, oh yeah, absolutely. And it was important to notice because we had everything was decoupled. Yeah. So the systems publishing to our event mesh. We had a microservice. I mean, it was like 200 lines of Python. You can go buy connectors and do all this, but it was pretty simple Python code running in Kubernetes. If we wanted to change databases, we would just change of the 200 lines, 50 of them were the ingestion call for the database. So and then, we knew we could always pivot if we needed to. That's great. But Azure Data Explorer is, if you're in Azure, it is a great platform. It's
super convenient to link up.
And it's also good for log data. So it actually came from. It runs log analytics.
Not log data as in web logs, like a Splunk type
Azure, tool. It's like Splunk. Okay. So Azure's log analytics, I think they probably built it for that. They built it to manage their logs and then made it a product.
Nice.
So we were able to capture all of this data, and then from there it could dump out to a data lake. So we were now capturing all of our tags, and that really helped with adoption. Like, do I want to change my tag structure? I got to buy these MQTT modules, and what's this for? Getting onboarding from all these different teams, or buy-in, from all these different teams. It was like, hey, you get all your data captured, and then we were also then go to pick a analytics vendor that could talk to lots of different sources. That was Seeq in this case.
Okay. And then, we talked about them a lot.
And then it could just index from Azure Data Explorer, but it can connect to a lot of different platforms. And basically at that point, give full historical access to all tags. So it was a lot easier to sell. Let's switch to this. Like, it's actually going to be easier for you to upgrade. Everything's more modular. Everything's easier to deploy and a little more in scope. And there's some challenges to shifting to it, but the benefits were we were more composable at the edge, and then we had this full data capture to the cloud, analytics platforms for self-service, all flowing through this event mesh. And so what was really cool is we were able to, it's really important to turn the data back to the subject matter experts. So for years we would get a request to say, build me a report for this meter's screwing up, and we'd have to go build a transaction group or use the ignition historian. We turn it on and build some screen, and then maybe they fix the problem, and then this work was kind of, it wasn't an efficient use of time. And a lot of problems in the factory are kind of transient. They come and go, or they're fixed, or they give up and just buy a new piece of equipment. There's a lot of ways it can go where it's not like an OEE enterprise solution. It's a little more ad hoc. So we were able to allow them to start solving their own problems. And a real satisfying part was when I would go to factories and ask people like, oh, are you using this? Are you aware? And they would just show all these problems they solved, projects they did, justified savings or cost avoidance from not needing to replace equipment, accounting of material consumptions, all these cool things, and doing it without the industrial applications team knowledge, which is huge.
Would they, sorry to interrupt you there, but would they, for example, if they're using an analytics tool like a Seeq, would the distributed teams be able to create their own capsules? And then how did you navigate between the centralized team and the individual teams on hey, here's an event, it involves a valve, a heat exchanger, or whatever. This is the capsule that's relevant, and what other sites of our 70 sites should look at that capsule and see it?
So anyone can build whatever they want, but then certain, we'll say regional teams or regional process engineering teams, they could start to enforce that this is the one you should use. Because if they're going to try and compare apples to apples, they want to make sure someone doesn't just go tweak a couple little settings in the formula to make them look better, or to try and justify savings. Not to say anyone would do that, but
I'm sure they would.
There's a lot of ways to derive metrics. So so it was kind of self-governed by the users, and basically the regional team, if you report to your region, the regional team could define this is the one it's going to go through. You can still go build wherever you want, but they kind of govern that. What else was really cool about allowing them to solve problems is when they would find a problem, you could automate it, right? So you could say, you could run some Jupyter notebooks in Python and kind of automate that collection. And then because Solace, supports REST publishing, we could actually then say, maybe start simple periodically, just once a day, go run and get your usage information for some assets. And we always try to always publish back to the broker. So if you're consuming events or reacting to that event data, always publish that back in. So as we liberate data from the edge and you stream and react to it, you're going to always share what you're doing. And because that always went into the time series database to the data lake, it kind of creates this feedback loop. So events get from the edge consumed to cloud. And it does kind of create this feedback loop where it just builds more and more, but every event's captured and every event goes to the data lake. So those derived events could start being automated. And so it could be on a timer and you post to Solace and then that gets consumed. But then, because Solace again supports multiple delivery modes, you could then write services to say, hey, automation team, publish an event when a certain process completes. Some sort of, maybe, equipment to equipment transfer or raw material, bulk raw material transfer.
And then could you
just publish an event when that happens? And first off, that event's useful because you can use it in reporting.
And then you can presumably you can do relative timestamps, not absolute timestamps.
Yes, you can overlay on top of
starting every time that you have an event.
But now when that event comes in, you can go to a queue, get delivered to an endpoint. or use AMQP, whatever made sense for that solution. And then you could say, hey, anytime this activity occurs, publish an event, and then that event's going to fire the workflow that's going to go look at that data that was just logged, do a summary, do an alarm, do an adjustment, and it's going to publish that back to the broker. If it was going to be something that may be adjusting a set point or making a recommendation for a set point, that's going to get routed back down to the site. Because we have that intelligent routing. So, and
I assume the site would have to approve a set point change. Something like a set point
generally,
change would presumably
so that could be
happen in autopilot.
That could be queued up, but and depends on how severe of a messing up the set point would be. but we had that route back for cloud to edge. So
nice.
We really found the path to be, you start with the self-service, drag and drop, build your trends, build your analysis using whatever tools you have. Then you can start to automate it, right? So you can be event-driven, have these events trigger it, transact on it, send events back out that can be transacted on, all being captured again for history. And then the goal, which we didn't get to, but is kind of the future now, we get agentic AI, is you can start to become autonomous. So now you can start being more prescriptive, to start saying these are the events I want to use, but then you can start saying like, hey, when these events occur, go start investigating from all of the skills that you have out there.
Nice.
And I think, I'm not there now, that's kind of where the future is going to go. But that's kind of the way you work your way up in terms of confidence and maturity to say, how much am I going to let this thing do on its own before we fully unleash it. But it was very much enabled by, MQTT at the core, but then choosing an event broker that allowed us to do that transactional data. We started bringing in more business systems and MES layers,
which is critical.
And another really cool thing that happened with that is we would bring in, there's a lot of, even here, like AI vendors, or we do predictive maintenance.
Thank you. That's my passion.
Yes.
Thank you so much for saying those two words.
And it was always, this is actually one of the catalysts too. I didn't think of when, there's complexity at the site, why we modernize. We'd have vendors come in and be like, well, we can predict X, Y, Z in your equipment, but we need 2 years worth of data of all these things.
Exactly.
So it's like, all right, well, we'll see you in 2 years because we'll go turn it on. And we had to be more proactive and MQTT allowed us to collect all that very in a lightweight manner. But then we actually have meetings with predictive maintenance vendors. They'd be like, well, can we get access to this data? And we could very quickly provision them, secure MQTT client. And then all of a sudden it was like within the meeting, they have all the data. Nice. And actually the problem being, instead of we don't have enough data or it's not contextualized, they're almost like, oh my God, there's so much data. There's so many, because you've got meters from 2 dozen sites.
It's hard to overstate how important that is. We were working with a governmental client whose name I can't divulge, but there was a major problem simply trying to get historical data out of the historian. In this case, it happened to be Pi, but regardless of the historian, there can be a lot of bureaucratic reasons that you can't get data out like that. And being on an advanced MQTT broker can you can test algorithms from multiple vendors on real historical data and then see, does your algorithm work or not? And it's a big barrier in the field. It's a legit barrier.
So we kind of predid some of the enablement. You start knowing, I don't want to be on this call again, where they say, we need this data, and we don't have it. And why don't you have it? Because no one asked. And it was that we can't be reactive anymore. We have to be proactive. And it's a lot cheaper to collect all that data now. And you can do tiered storage to make it doesn't always have to be quickly accessible, although it's not that expensive to be quickly accessible. But either way, so that was actually another one of those moments that was like, you get the little pride point of that they're surprised that you can get all that data in. So a lot of thought went into the topic structure and how we do that, and do we do UNS, do we not do UNS, or how are we going to approach it? And working with Solace, again, they had a lot of content and educational material that probably influenced some of my decision making because they've been doing it for 20 years. So that's their game. So I kind of took their guidance on kind of how to make it more composable. So how do you make events that are more easy to transact with, easy to route to stream processors, and then on top of that, more composure UNS. So the UNS would be more of a experience layer where the end user can say, it's hard to get agreement on what the full semantic layer should be.
That was my next question, actually. Where do you land philosophically on it? Does the UNS need to be in the center of all the traffic, or can you layer it one abstraction layer higher, and then you can actually have multiple interpretations at that UNS layer?
From my experience, more central. And the definition, at least, can be central, and that needs to be more contextualized right to the user. Now, the definition up there, now, if you have an agent running down at the site that's going to take some of that raw data and publish as a UNS, that's fine. But I think I always had trouble. It was hard to get consensus on things, right? So it's hard to get a lot of teams to agree on naming, right? You go to your CMMS, your MES, your ERP, and then you go to the SCADA even, like the names don't always match. It's close, but not the same, so which one you're going to use, and then they're going to write. It's hard to get naming and consensus, and then also if you want to change it. So now how am I going to coordinate all these teams changing it? And the only way to get around that then was to have this, one gateway or one data ops piece that's now kind of this critical piece that aggregates everything, and now you're getting into this game where everything needs this other person or team or approval to manage change. So it was more of what's a simpler structure that everyone can publish kind of in their terms. Can you follow these guidelines? Like, here's a couple levels in a format. Publish your Sparkplug data this way. Publish your raw events this way. Please abide by this. And if you do it, you get all these great features and all these other services that the central team is going to offer to you. And then once that's kind of all documented and captured in the cloud, then you can build a semantic layer on it and say, so if I go to historically, I want this data, I can compose that historical data. If I want to push that out as an agent that just basically says, here's all the semantic hierarchy has all these references. Can I go now go query the raw streams because it's a reference to a raw stream. Pull that in and then basically publish that out in real time. And then you can even go bidirectional if you wanted to.
Oh, no, okay.
So I really think it's kind of akin to like the notion, something from MuleSoft, like of system APIs, processor domain APIs, experience APIs, right?
Nice.
That usually when you're going to a website, you're going to an Amazon, you're not hitting the back end, right? You're hitting these layers that are built for your use case to show you the data in the format you need, or to serve, in this case, the front end.
You got it.
And then layers underneath that compose all the various systems at play. So it's really like, how can we do that in an event-driven manner? Nice. And again, that's where Solace really kind of helped probably guide my thinking there, because there's products to help design that. Right?
Nice,
to design your EDA, build your async APIs. So you can really have this kind of layer where everyone can still own their piece and just abide by some rules, document it a certain way, and then you can build those layers on top. So I like to think of it as more composable industrial systems.
Totally. And I'm already over time, but I have to ask you one more burning question.
Sure.
That semantic layer, was the semantic hierarchy rigidly hierarchical, meaning parent-child relationships all the way down the stack?
Yes, but not necessarily by choice. That was probably more out of necessity. So I'm guessing what you're alluding to from our previous conversations.
I'm 100% leading the witness.
Graph databases.
Graph databases,
I wish it was, and it still could have been. It was mostly just from our side a limitation of we wanted to build a front end. So I didn't want to be the one to go build that layer. It's going to be more, hey, you're the SME, you're trying to do an analysis of a reactor system, and you know that this recirc loop is this pump and this valve and this and this and this. You can build the hierarchy that makes sense to you and then perform your analysis on it. To do self-service, just from my skill set or the team skill set, it was easier to do it with like parent-child relationship.
Much easier to digest,
and I think there's some vendors now doing it, where it's easier to build that graph database or graph model on top, and if that graph can then semantically represent underlying assets, existing in a source. And I know like Flow Software was showing that.
That was one of my favorite announcements from this week. Was
so now
Flow doing a graph.
It's very much aligned to that, and that's why I was really excited to talk to them about it. Now you have your data sources, which in our previous case would be coming from these event streams, and then you can kind of compose whatever you want on top, and assuming you can query that, you could also build something to republish it back out.
Which is
maybe Flow can do it, but if not, you can do it yourself too.
Dan, I'm way over time. This has been amazing. We are definitely going to talk again. So let's put a pin in it. Let's talk graph databases next time and how you build out the enterprise ontology, and that'll be a lot of fun.
That'd be great.
Awesome, man. Thank you so much.
Thank you.
Appreciate it.
Thank you.